Welcome back to Rice.AI Code Room. Today we are tackling LeetCode 2573, find the string with LCP. The problem provides us with an n by n matrix named LCP. The value at LCPij represents the length of the longest common prefix between two suffixes of a string, one starting at index I, and the other starting at index j. Our task is to reconstruct and return the alphabetically smallest lowercase English string that exactly produces this LCP matrix. If it's impossible to form such a string, we must return an empty string. To solve this, we can break it down into two steps. Step 1 is greedy construction. Notice that if LCPij is greater than 0, it implies the characters at index I and j must be identical. We can iterate from the first character to the last. Whenever we find an unassigned character, we assign it the smallest available letter starting from a, and we also assign the same letter to all positions j where LCPij is strictly greater than 0. If we run out of 26 letters, no string exists. Step 2 is validation. Even if we formed a string, it might not satisfy all LCP constraints. So we compute the actual LCP matrix of our generated string using dynamic programming from right to left, and check if it perfectly matches the given matrix. If it does, we return the string, otherwise an empty string. Here is the C++ code. First, we initialize a string s of length n with spaces, and start with the character a. We loop through the string. If a character is already filled, we skip it. If we've used more than 26 letters, we return an empty string. Otherwise, we scan the LCP row I, and for any index j where LCPij is positive, we assign character c to s of j. Then we increment c. After constructing the string, we validate it. We iterate backwards and compute the expected LCP using the recurrence relation. If characters match, it's 1 plus the diagonal element LCPi plus 1j plus 1, else 0. If the expected value doesn't match the given matrix at any cell, we return an empty string. Finally, we return the constructed string. For the complexity, the time complexity is O of n squared, because iterating through the matrix for both string construction and the dynamic programming validation takes n squared operations. The space complexity is O of n, as we only need to store the resulting string of length n, and the validation operates in constant extra space. Thank you for watching.